In this video, we are going to be taking a look at systems of linear equations. So let's start from scratch. What is a linear equation in and of itself? Well, it's any equation that follows the form a1x1 plus a2x2 all the way until we've used all our variables and everything gives us a sum of a constant b. Let's take a look at a very basic example. Here we have x plus y plus z is equal to 24. Now remember, our variables can be used to indicate basically anything that we want. For example, I could be running some sort of factory where x represents the number of cars produced, y represents the number of batteries produced, and z represents the number of GPUs I produced. So let's take a look at this equation one more time and try to figure out what it's trying to tell us. Well, it's saying that if you take x, the number of cars produced, and you take the number of batteries produced, the number of GPUs produced, and you add that all together, you would get 24, and that would be the number of products, so you would have 24 products in total. Pretty cool. Let's take a look at another linear equation. This time we'll have 200x plus 20y plus 160z equals to 3,900. So this time our variables have coefficients in front of them, and it's important to note that these coefficients tell us something important about our variables. And again, that could be anything that we want. For example, in this case, they could be talking about the price of these products. In this situation, 200 can represent the price of a single car, and if you multiply that with x, the number of cars produced, you would be looking at the entire value of all your cars combined. You can do this with the number of batteries produced and the number of GPUs produced, and this linear equation is telling you that all of those values combined would give you a total value of $3,900. In other words, your factory has produced a total of $3,900. Alright, so let's take a look at one last example. Here we'll have y minus 2z is equal to 0. This time, our linear equation is telling us that if you take the number of batteries produced and you subtract 2 times the number of GPUs produced, you'd end up with nothing, no products. Essentially, it's telling us that there are twice as many batteries as there are GPUs. Great, so we've looked at 3 linear equations so far. One was talking about the total number of products, another one was interpreted as the total value of all of these products, and another one was talking about the relationship between two products. So we're getting a pretty good understanding of what a linear equation is, but what in the world is a system of linear equations? Well, funnily enough, we've actually already created a system of linear equations. A system of linear equations is very simple. It's basically a collection of linear equations that are utilizing the same variables. So in our case, all of our linear equations are using the number of cars produced, batteries produced, GPUs produced, and so that would create a system of linear equations. So as we mentioned, because a system of linear equations is using the same variables over and over again, it might get tedious to write them down repeatedly. So we can use the augmented matrix, where we can keep the coefficients of our variables and take out the variables themselves. Here's what the augmented matrix would look like for this system of linear equations. So just having our x would be the same as having a coefficient of 1, same for y, 1, 200, 20, 160, 0 for the x, 1, and negative 2. Now, in reality, we could be representing this system of linear equations as two matrices, one for the variables and one for the results. But because we want to represent our system with one matrix, we can use this straight line to represent the equal sign and continue with our results. So we'd have 24, 3,900, and 0. Now, in an augmented matrix, we won't be shifting our numbers left and right anytime soon. So we can know what variable a coefficient is referring to by the column that it's in. So for example, all the coefficients belonging to x would be in the first column, all the coefficients belonging to y would be in the second column, and all the coefficients belonging to z would be in the third column. Awesome. So in this video we cover what linear equations are, what systems of linear equations are, and how they can be represented on an augmented matrix.